Hi guys, so today we're going to be doing a lab demo about looking to see if the temperature of water affects how long it will take an antacid tablet to dissolve. So we have our Alka-Seltzer tablets we're going to be using. We have our cups of water down here. We have hot water, we have room temperature water, and we have cold water. So our testable question is, does changing the temperature of the water affect how long it takes an antacid tablet, Alka-Seltzer tablet, to dissolve? Okay, our materials, we're going to be using 3 different tablets. We're going to have our 3 cups with water, right? Each cup's going to be a different temperature. And then we're going to be using a stopwatch in order to time how long it takes to dissolve. So if we look at our procedure, it says fill one cup up with hot water, drop in an antacid tablet, time how long it takes for one tablet to fully dissolve where you can no longer see any solid pieces, record the time and your observations in the data table. Then it says fill 1 cup up with room temperature water, drop in the antacid tablet, time how long it takes for the tablet to fully dissolve, record the time and your observations in the data table. Fill 1 cup up with cold water, drop in an antacid tablet, time how long it takes for the tablet to fully dissolve, record the time and your observations in the data table. So the first thing that it asks us to do is to write a hypothesis in the if, then, because format. Okay, so if we increase the temperature of the water, then here's where your choice comes in. You're either going to predict that it's going to take less time to dissolve or more time to dissolve. So if we increase the temperature of the water, then it will take more or less time to dissolve because, and you're going to give your own explanation. So take a pause right now, go over to your Google Doc, type in your hypothesis. Okay, now that we've made our hypothesis, we need to identify the different parts of our experiment, okay? So the first thing that it asks us to identify is the independent variable, and that is the thing that we are changing on purpose between our 3 trials. So if we look here, the thing that's going to be different between our 3 different trials is the temperature. We have hot water, we have room temperature water, and we have cold water. So that would be our independent variable, the temperature of the water. Then it asks us to find our dependent variable. So that's going to be the thing that is being affected by the changing water temperature. So we are trying to see if changing the temperature of the water affects how long it takes to dissolve. So our dependent variable there would be the time it takes to dissolve. Make sure that you take a pause right now, you go back to your Google Doc, and you make sure that your independent and your dependent variable are typed into your chart. The next thing that it asks us to identify are constants, at least 2 of them. Okay, so constants are things that we make sure that we keep the same between our trials. So we are always using the same brand of antacid tablet, which is Alka-Seltzer. We're using the same size of Alka-Seltzer tablets. We're using the same amount of water in our cups, right? The levels are the same. So all of the same type of cup for all of our different trials. So all of those would be constants. You want to pick 2 of them and go take a pause and write that into your chart on your Google Doc. Next, it asks us for the control. Okay, so the control is the trial that is as close to normal as possible that we're going to use for our comparison. So when we look at our 3 trials, we have hot water that we're going to dissolve it into, we have room temperature water that we're going to dissolve it into, and we have cold water. Usually, if you're going to dissolve an Alka-Seltzer tablet, we use like room temperature water. So that would be our control that we can compare a hotter and a colder temperature to. So our control for this would be the room temperature water. So take a pause and go write that in your Google Doc. And then the last thing it asks us is about the data. Okay, so it asks us what type of qualitative and what type of quantitative data could we collect. So qualitative data is going to be observation-based using your senses. So you're going to choose something. It could be the sound that each one makes. It could be the size of the bubbles that each one makes. It could be anything that you can use your senses for, right? So pick one thing that you're going to observe as we do the trial, whether it's the sound, the sight, something, and try to be specific. Don't just say how it looks, right? Say specifically the size that the bubbles look, something specific. And take a pause and go write down what type of qualitative data you're going to collect. And then the last thing it asks us for is quantitative data, what type of number data we're going to collect. And for this, we definitely have to collect time, right? Time is a number. We have to record how long it takes to dissolve. So I would make that my quantitative data. So make sure that that is written in your Google Doc. Now that we've identified all the different parts of our experiment, we need to do our experiment. So as we do our experiment, you're going to write observations, okay? And then you're also going to, at the end, right, record the temperature in the time that it took to dissolve in seconds. Okay, so make sure as you watch, you're thinking about what to put in your two data tables. So according to the procedure, we should do the hot water first. Okay, so I'm going to have my hot water here. I'm going to have my tablet. As soon as I drop my tablet in, I will start the time. So it's dissolving. I have my time going. You can see some steam coming off the cup still because it's pretty hot. And I would say right about now, there's no more solid pieces. So I stopped my timer, okay, and it took 19.09 seconds, okay. So opening up your Google Doc, looking at your Google Doc, the first data table is for observations, okay. So whatever you said you were going to observe, if it was the sound, if it was the size of the bubbles, whatever it was, make sure you write a couple of observations in for the hot water cup, okay, what you saw happen. And then the second data table below that is for time. So you're going to record the time that it took, 19.09 seconds to dissolve. Now we're essentially going to repeat the same thing, but with our room temperature cup. So I'm going to reset my stopwatch so it's back to 0. I'm going to pick up my room temperature cup. I'm going to take my next Alka-Seltzer tablet. As I drop it in, I'll start the time. We'll watch it dissolve. Let's float it up to the top now. So you wait until you don't see any solid pieces, which is right about now. So I'm going to stop it. Okay, so again, we look back at our data table. The first data table on top asks for observations. So you're going to record some type of observation that you made as you were watching our room temperature cup Alka-Seltzer dissolve. And then the second data table below it is where you're going to write the time. The time that it took for our room temperature was 41.56 seconds. 41.56 seconds. So you're going to put that in your data table. Then we're going to reset our stopwatch back to 0. We have to do our last trial. So we take our cold water, we take our Alka-Seltzer tablet. As soon as we drop in the Alka-Seltzer tablet, we'll start the time. Okay. So the tablet's still at the bottom right now. Watch it dissolve. So you can still see it down here. Okay, floated to the top. So now we look from the top until all of these solid particles have dissolved, which is right about now. Okay, so we stop our timer. So this was 1 minute, 14 seconds, 0.43 milliseconds. And the thing that we have to remember is that our data table specifically asks for the time it took to dissolve in seconds. So we don't want to say 1 minute and 14 seconds. We want to convert all of it to seconds. So we have to think about how many seconds are in a minute, okay? And there are 60 seconds in a minute. So we're going to basically change the 1 minute to an additional 60 seconds. So we had 14 seconds plus these 60 seconds over there. So that would give us 74.43 seconds. Okay, so 1 minute and 14 seconds, 0.43. But if we convert all to seconds, we change that minute to 60, 60 plus 14, we have 74.43 seconds. So that's what you're going to write in your quantitative data table for the cold after you write some observations for the cold cup in the data table above it. So now both of your data tables should be filled in. Your observations table should be done. Your quantitative data table with our time should be finished. Okay. So now all we have left to do is make a conclusion. Okay. So looking at the times, right? Hot took 19 seconds, room temperature took 41 seconds, cold took 74 seconds. It asks you to make a conclusion. Okay. So it says increasing the temperature, right, of the water will cause it to take and then more time or less time to dissolve. So you have to look at your data and figure out, did increasing the temperature, the hotter it was, right, did it take more time to dissolve or did it take less time to dissolve? So you're going to highlight whichever of those statements is true, either more time or less time. And then looking underneath that, comparison to your hypothesis. Okay, so you have to look back to your original hypothesis that you made. So you're going to compare it to your original hypothesis, right? On the beginning of your Google Doc, at the start of our experiment, you made a prediction, right? You did our if, then, because. You said if we increase the temperature, then you predicted if it would take more time or less time, and then you gave an explanation. So now we're going to compare it to our results, right? Did our results match your original hypothesis, which means that your hypothesis was supported, or did it not match, which would be unsupported? So you're going to highlight whichever statement is true. Remember, your hypothesis does not have to be correct. Okay, it is an educated guess, but it's still just a guess. So about 50% of the time, you're probably going to be wrong, right? That's totally fine. Don't go back and change your hypothesis, right? Leave your hypothesis what it was, and you just highlight either supported or unsupported. Okay, and that's going to be the end of our demo today.